Hello everyone, I hope I'm audible to you all. Hi. How are you all doing? So yeah, it's been quite a while that I've not made any videos. Okay, so today I'm going to bring you one very interesting problem. It is a CMI PYQ. Okay, so I think it is CMI 2014 PYQ, so 12 years back, and I'll just go through it. It's a, you know, ISI CMI PYQs, what's the special thing is that they ask a lot of theoretical questions. So the questions in JEE, generally, they can be solved using L'Hopital's rule or something, and you can finally get the answer. But here also you can use L'Hopital's rule, but the point is the knowledge behind L'Hopital's rule is more important. Okay, so that was just an example, but look at it. Look at this question. Let F be, so it is a two-part question. This whole question has two parts, one and two. F be a continuous function on -1 to 1 and differentiable, and it is differentiable at 0. That is important. For x not equal to 0, define a function g such that this x cannot be 0 because x is there in the denominator. Okay. Can g of 0 be defined so that the extended function g is continuous at 0? Can g be made continuous at 0? That's the question. So it is not defined at 0, right? So how do we define g of 0? So naturally, the first this thing is we'll take limit x tends to 0 g of x. That's what we want to define as g of 0. We want to define g of 0 by this. So what is this limit? Let's take it limit x tends to 0 f of x minus f of 0 by x. Now, if you notice, this is precisely the definition of differentiation. This is f dash of 0. This is the definition. Definition of derivative. Okay, this is how we define derivative at 0 of f of x. And is this valid? This is valid because it is said f is differentiable at 0. Okay, so that's it. Uh, so we know how to define g of 0. G of 0 we defined on the extended. Yes. So therefore, I can say g of x is a continuous function such that g of 0 is equal to f dash of x, f dash of 0, and g of x is equal to f of x minus f of 0 by x when x is not equal to 0. So this is the extended function g of x. All right. So now what do we want in the second part? For f as a part, as in part 1, show that the following limit exists. So this limit has to exist. This is a very interesting thing. So f of x by x, f of x by x. So we are taking this limit. So so if you look at it carefully, it is actually trying to be the limit of -1 to 1 f of x by x dx. But obviously, because between -1 to 1 there is 0, and here the domain we cannot directly take 0. So how do we define this and all is the problem. So it's a very interesting question. Okay. Acha, do you all know what are the fundamental theorem of calculus? I hope you all understand that there are two parts, but one of the parts says that if f is continuous, right, it implies anti-derivative of f exists, right? In our case, f is continuous, yes. In our case, g is also continuous. G is also continuous, right? G is also continuous. So we just derived it. The first part was deriving. G is continuous. All right. Um, so if you look at it, integral -1 to minus r, f of x by x. Doesn't it seem like it is, what is f of x? First of all, remove the integral part. I'm presently only interested in what is f of x by x. We already know g of x. So g of x is equal to f of x by x minus f of 0 by x. So that implies f of x by x is equal to g of x plus f of 0 into 1 by x. So this has to be clear, right? So let us look at each of the integrals. So first part of the integral, uh, integral part 1, I can write it as minus 1 to minus r, where r is positive. If you notice the integral, r is 0 plus, 0 plus, the limit. In the limit, r is 0 plus, okay. So what do I do? F of x by x dx. This will be equal to minus 1 to minus r g of x dx. Um, hmm, g of x dx minus this minus plus f of 0 integral minus 1 to minus r 1 by x dx. And if you remember, what is integral 1 by x? Integral 1 by x is defined to be natural log of mod minus x. All right, this is natural log of mod minus x. I mean, basically look at the area. Whenever x is positive, the area is positive. But whenever the x is negative, the area is supposed to be negative. So even if you take natural log, because of the direction minus 1 to r, this to this, the minus 1 to minus r. So I think it will be negative. So let's see. So I will write it as the whole integral I1 as minus 1 to r minus r g of x dx plus f of 0 into mm, ln mod x, where you take it from minus 1 to minus r. So there we go. And we know that at minus 1 it is 0. So we'll simply have integral minus 1 to minus r g of x dx. And since integral denotes this, it cannot be a positive quantity. It has to be negative f of 0 ln r, right? So this is part 1. What is part 2? Part 2 is integral from r to 1 f of x by x dx. That is integral from r to 1. Uh, okay, wait. I don't think it will be minus. It will be plus only. There's no minus. Okay. R to 1 g of x plus f of 0 r to 1 1 by x dx. And you'll notice this is integral r to 1 g of x plus f of 0 ln mod x from r to 1. So you'll notice that I2 is equal to r to 1 g of x dx plus f of 0. So here we'll have minus actually log r. All right. So this is there. What do I do? What do I get? Hmm. All right. My main integral is I1 plus I2. So now I'm going to simply add, before putting the limits, I'm going to add this, this, add this. So my I is what? I is equal to, mhm. So I'll save some space actually, if you can. Then I'll write my I2 here itself. Okay, anyways, just write it. क्या फर्क पड़ता है? If you notice, if I add those two terms, you'll see that these two terms get cancelled. This gets cancelled with this. So I'll be left with I is integral minus 1 to minus r g of x plus integral r to 1 g of x. Because plus or minus f of 0 ln r gets cancelled. Now you understand what is antiderivative. What is antiderivative? That implies integral from a to b f of x. Let's say this antiderivative is capital F. This happens to be capital F of b minus capital F of a. That is the antiderivative, right? Right. So now I will use the antiderivative property. Let's say g is the antiderivative of g of x. That implies I is equal to, since g is continuous, I is equal to g of minus r minus g of minus 1 plus um, g of 1 minus g of r. Now I want you to notice another thing. Uh, g is also continuous. Integral of a continuous function is a continuous function. So antiderivative of a continuous function will be a continuous function. It makes the function even smoother, if you know what I mean. So this will imply that limit r tends to 0, positive or negative, g of x, g of r goes to g of 0. So do you see what happens to the sum? I simply becomes g of 0 minus g of minus 1 plus g of 1 minus g of 0. So g of 0 gets cancelled. This is simply g of 1 minus g of minus 1. Right? Okay. Now, the thing is, how do you find g of 1 and g of minus 1? What is g of 1, g of minus 1? Okay, first of all, what is this? This is simply integral between minus 1 to 1 uh, g of x dx. So I think this is it. You can only say that this limit exists. Oh, that's what we need to show. Show that this limit exists. Yes, it exists. This is equal to integral minus 1 to 1 g of x dx. It exists. This is a finite value because g is continuous and all that. All right. So yeah, I hope you understood the question and I hope you found it interesting. All right. I'll be bringing more such questions. Yeah, but before that, there is this amazing sale going on, right? Freedom sale, we're calling it, copied from Amazon, I think. But anyways, it'll end on 16th August, guys, and this batch, particularly target math, which I already talked about in all of my previous videos, you know that it's this amazing batch. But the thing is, the price is dropped off now to 10,000 rupees only, guys. 10,000 rupees only, 35%. This is massive. Okay, this is massive. um, Chetan sir, the amazing sir. Okay, I'm not selling the batch. My main point here is the price has dropped off. So I want you to take full advantage of this. Um, this is really crazy. 15,000 to 10,000. Like, come on, that's 5,000 something change. I don't know how Vedantu is bearing that. But anyways, and the second batch, this is the evening batch, which is taken by Krishnendu sir. He is a new teacher and people are loving him. Any student I'm asking, they're just loving him. He is crushing it. All right. He has a unique style of preparing the slides. He does it himself. He has a huge knowledge. He completed his PhD in ISI. In ISI Kolkata, he was doing his PhD. I met him. He was my senior. And anyways, so he's going to make you prepare for ISI and CMI like anything. You'll see the results crazy. Here also there is a massive price drop. This batch is also being sold for you only for 10,000 rupees, 9,999. Amazing, amazing uh, price drop this is. Okay. So I just want you to take full advantage of this. This will be there till 16th of August. Don't miss it out. Don't miss it out, my dear brothers and sisters. All right. So make full use of it, and all the best. Take care.